I'd like to thank you all for coming again. Please note we're going to have a very full crowd, so if there's any empty seats in the middle of your row, if you could please move in, that would be great. We have people next door that we'd like to move over for seats as well. Thank you.
Good evening. Good evening. Wow, that's great. You guys are charged. Welcome to Aquinas College. I'm Kevin Quinn, president of the college, and we are just thrilled to have a house full of both old and new friends with us tonight. And not only do we have all the folks that are here, but we have an overflow room in the back, and I think we have something like over 400 people here tonight. That's just wonderful. I'd especially like to welcome our featured speaker, Brother Guy, who's a premier scientist astronomer and also a Jesuit brother, but we'll hear more about him in just a moment. Aquinas College is the only Catholic college in West Michigan, and like the church itself, we take science very seriously here. We are proudly named for St. Thomas Aquinas, one of the most scholarly and learned people in Western history, and whose likeness you saw if you entered the campus from Fulton Street. You couldn't miss it. It's like 30 feet tall. St. Thomas studied across many fields, including in the natural sciences, and he was tutored by another towering intellect in the person of Albertus Magnus. Thomas Aquinas is famously known for his understanding of the harmony between faith and reason, something that means a great deal to us at this institution. The last few months offer a concrete example of how we think about this. Within the span of about 2 weeks, around the 1st of October, we dedicated the beautiful brand new Our Lady Seat of Wisdom Chapel that sits at the very center of our campus. Right around the same time, we also broke ground for a brand new science facility project that both renovates and significantly expands our existing Albertus Magnus Science Hall. Faith and reason. If you came onto campus from Robinson Road, you can see the progress of that project. The new wing of the science building, which is named after our very own Sister Mary Aquinas Weber, who I think is here somewhere, right over there. How about a round of applause for Sister Aquinas? So she's going to be right there next to Albertus Magnus. We'll have to call you Aquinas Magnus, maybe. But the new wing of the science building will be ready for occupancy in the fall of 2019. That's coming up very quickly, with the rest of the building completed in 2020. The chapel and the science building are two elements of our Contributing to More campaign, which is designed to help Aquinas College move toward a bright future. Also included in the campaign is work toward supporting additional undergraduate research, which helps our students prepare for medical school, helps them prepare for graduate school and jobs. It supports a number of new and existing academic programs, including those in the health sciences, engineering, biochemistry, molecular biology, geographic information systems, and several other things I don't understand. It also will help support bridge programming for underrepresented students in the STEM fields, which is a key part of our science mission at Aquinas. We would love it if you'd be willing to support our students who are so important to the future of Grand Rapids. There are baskets and envelopes available for you to help them out, and every contribution makes a difference, so thank you in advance for that. And thank you so much for joining us here tonight. I will now turn things over to Sister Damian Marie Savino, who is our wonderful Dean of Science and Sustainability here at Aquinas, and really the shepherd of the science project, who will introduce our distinguished speaker. So thank you and welcome.
Thank you very much, Kevin. We are just so delighted to see so many people here from the college and from around the community.
Both science and religion are conversations about the universe.
You leaned on the machine there.
I leaned on the machine. Well, that's great. You got a preview. It was one of those God things. Oh, gosh. Well, I first want to, I think, before we would begin with my introduction of Brother Guy, I do want to say some thank yous because, as you can imagine, there was a lot of behind-the-scenes work to put together an evening like tonight, and I owe a great debt of gratitude first to our co-sponsors, so John Pinero and the Catholic Studies program. They do an awful lot of work on campus and in the community with integrating faith and the disciplines. And so, John, I thank you very much for your support. And then the Franciscan Life Process Center in Lowell. And Brother Guy will be speaking to a full house there tomorrow evening as well. And I would like to thank Sister Margaret, Sister Colleen Ann, and the Franciscan Sisters of the Eucharist for their support of this event. So. And now Cindy Chapman is our administrative assistant for the sciences, and she has done so much behind the scenes. All your labels, all the organization of the food, the chairs, all the things you have placed on the chairs, she very carefully and cheerfully did, and she has spent many, many hours on this. So I want to personally thank Cindy for her work. And then Mark Schmidbauer, the manager of conferencing services, who put this all together for us so beautifully and who's been so attentive. Our catering department, who did all the food, which I hope you're enjoying. Angela Butterfield and the communications crew, who were, again, very attentive to all the signage, all the publications that you probably received advertising this, all the media. So thank you to all of them. Okay, now a few logistics. On your seats, in addition to the information on our science initiative, are some evaluation forms. And at the end of the lecture, it would really help us out if you wouldn't mind filling those out. And there's a basket on the table in the back, if you could place those in there. So just help us to know how we can better serve you in the future. And then after Brother Guy talks, we will have Q&A. And we'll direct you in that, but the two microphones on the sides are where you are to line up for the Q&A after his lecture. And now we get to our introduction of Brother Guy. Brother Guy Consolmagno is a Jesuit. He's the director of the Vatican Observatory and president of the Vatican Observatory Foundation. He's also a Jesuit brother and a prominent astronomer. He's a native of Detroit, Michigan. He earned his undergraduate and master's degrees from the Massachusetts Institute of Technology and a PhD in planetary science from the University of Arizona. Before he entered the Jesuits in 1989, he was a postdoctoral research fellow at Harvard and MIT. He served in the U.S. Peace Corps and taught university physics at Lafayette College, a college kind of like Aquinas. He's worked as a Vatican Observatory astronomer since 1993. Brother Consolmagno's research explores the connections between meteorites, asteroids, and the evolution of small solar system bodies. It sounds fascinating. His work has taken him to every continent on Earth. For example, in 1996, he spent 6 weeks collecting meteorites on the blue ice regions of East Antarctica. Along with more than 200 scientific publications, Brother Guy is the author of a number of popular books, including Turn Left at Orion and Would You Baptize an Extraterrestrial? So he's, constantly searching, constantly asking, constantly communicating. He has hosted science programs for BBC Radio, appeared in numerous documentary films, and served as chair of the American Astronomical Society's Division for Planetary Sciences. In 2000, the Small Bodies Nomenclature Committee of the International Astronomical Union named an asteroid 4597 Consolmagno in recognition of his work. In 2014, he was awarded the Carl Sagan Medal for Public Outreach by the American Astronomical Society's Division for Planetary Sciences. Now, he has so many accolades, I could take his whole lecture time introducing him, which I don't want to do. But so he's basically, we're so gifted really to have him here. He's just a wonderful scientist, a writer, and a leader in helping people bridge their scientific and religious understandings of the cosmos. And so we're really delighted that he's agreed to be here with us. And please join me in welcoming Brother Guy.
Thank you. Thank you. It is fantastic to be back home in Michigan. And I stayed last night in Ann Arbor, and just driving across 96, all the places I remember as a kid, and all the places, it's just great to be home. Before I get into the talk, I know that there's a lot of curiosity about the Vatican Observatory, and so as you see, we've got this little film clip. And I'd like to start first by asking if you can bring down the lights, and I'll show this little movie, which gives you an idea of who the observatory is. From that, we'll launch into the topic that I actually want to get to tonight.
Both science and religion are conversations about the universe. They're ways of learning how we interact with this universe. It's not simply a question of, is there a God, but there is a God, now what do we do? It's not just a question of, there are a bunch of stars, but rather, why are there stars? How do they work? How does that tell us how things work here on Earth? The interaction that I see in my own life is that religion gives me the reason to do the science.
Back in the papacy before Francis was Benedict, and one of his lines in a final elocution to the fathers of the General Congregation was, "Go to the frontiers." Well, there isn't much more frontier than 3.7 billion years away.
The first official interest of the Church for astronomy started in 1582 with the reform of the calendar. Then in 1891, Pope Leo XIII wanted to have an observatory to show that the Church is not against science, but the Church promotes good science.
They start out by having telescopes on the Tower of the Winds, and then on the walls surrounding the Vatican, as the city lights grow, and as the Italian government gives them back the territory out in Castel Gandolfo. In the 30s, they build new telescopes on the roof of the Papal Palace in Castel Gandolfo, best telescopes of their era in the 1930s. By the 1980s, light pollution makes those telescopes unusable, so we build a new telescope in the dark skies of Arizona.
I'm Father Jean-Baptiste Kikwaya Eluo. I'm working in 3 projects. The first one is NEOS, Near Earth Object. So what I'm doing with NEOS is just observe them using our modern telescope VAT. The second project is meteors. I worked on very faint meteors, what we call shooting stars. And the third project is set fireball network. They will have 4 cameras here around Tucson so that actually we can monitor any fireball getting into the Earth atmosphere in the region.
This telescope, the Vatican Advanced Technology Telescope, it was the first of the new technology telescopes that has been considered pretty much the norm now in developing telescopes. With the advance of computer technology, we have the capability of bringing that advanced technology directly into our telescope. So it's an expandable, it's almost like it's a living machine, so it can grow as technology grows.
It is still very important to maintain scientific research at the Vatican, simply because there is still a lot of confusion about this relationship between science and faith. We are not out here trying to prove the existence of God by looking through a telescope. That's not what we're doing. But we can say that if we want to obtain any reasonable results looking through that telescope, we need to do it embracing a certain work ethics that is, in fact, the same work ethics that the Bible itself tells us through commandments and through the Gospels to embrace.
Human beings look at the stars and wonder. They want to know, what is that? What is that about? How do I fit in? They hear about the moon landing and they want to know, what was that like?
Very well.
If we're part of the human race, we're part of the race that went to the moon. We're part of the species that looked at the stars and wondered, what the heck are those things? Looking at the sky reminds you that there's more to the universe than what's for lunch. What's more, if you believe in a universe that God so loved that he sent his son, then not only are you going to want to study the universe because it's kind of cool, it's an act of worship. It's an act of getting closer to the Creator and getting closer to a universe, as St. Athanasius said 1,500 years ago, was cleansed and quickened by the Incarnation. Then, doing science is an act of worship.
So this is going to be a science religion talk, right? And part of the trouble in giving these science religion talks is that a lot of people have an experience with religion, for better or worse. Fewer people are probably active scientists. How many people in this room, raise your hand, would call yourself a scientist? And it's a pretty good crowd, but even so, you can see you're in the minority. So what I thought I would do to launch this, to really give you an idea of where I think I'm going, is to teach you a little bit of science by doing a little bit of science. So here we've got a very, very famous photograph of the moon. This is a picture that I used to show back in my Peace Corps days, back in the early 80s. The kids in Africa loved it because there's Africa. They could see themselves. And you've probably seen pictures like this all the time. That's Africa. Right in the center is Kenya. What time of day is it in Kenya when this picture was taken? Daytime or nighttime? Daytime, obviously. The sun's shining. Is it morning or afternoon? Is the sun, is the earth about to turn into the shadow, or has the earth just turned out of the shadow? How many people say morning? And how many people say afternoon? And how many people aren't sure? Where's the sun? Over there. So if I'm standing on Kenya, which way am I looking to see the sun, east or west? Is it morning or afternoon? It's afternoon. Okay. What season is it in Kenya when this picture is taken? It's a trick question. Kenya's on the equator. It doesn't have seasons. You can see there's cloud. When I tell this to my students, I say, it's the rainy season. And they're right. In the northern hemisphere, which season is it? And the earth is tilted, so you can see the shadow there, but the pole is pointing so that the northern hemisphere side is pointing towards the sun, the southern hemisphere side is pointing away from the sun, so it's summertime in the northern hemisphere. You can see that there's, it's completely dry and cloudless over the Sahara Desert, over Arabia, over Italy, over Spain. If you look carefully, England is exactly covered with a cloud exactly the shape of England, therefore it must be summertime. Okay. What day was this picture taken? What year was this picture taken? Some people are saying 68. It's far enough away from the Earth that you can see the entire globe. So it had to be a spacecraft that was moving far away from the Earth. It's a clear enough picture that this was taken with a Hasselblad on real old-fashioned chemical paper. This was not a television picture, because back before 1963, when I was in the 83, when I was in the Peace Corps, they didn't have TV cameras good enough. Were there any missions to the moon in 1968? Yes, there was. When was it? Christmas time. So this was not 1968. When was the trip to the moon in 1969? July. So could this be the Apollo 11 picture? Could this be that it was sometime in that week between July 16th when they launched or July 24th when they came back? Apollo 15 also went to the moon during the summertime. But its path was a little bit below the equator, and so you got more of a shot of the southern oceans. You didn't get a shot like this, so this has to be Apollo 11. Now, you're going to say, wait a minute. That last bit, you had to know things that aren't in the picture. You had to know something about, my story and when I was telling it and that I showed it to kids 30 years ago and so on. That's cheating. In science, there's no such thing as cheating. You take your research, you take your information wherever you can get it, and you apply it. But now, notice what we've done with this picture. You've seen this picture a dozen times, a million times. Now you know to look at the picture and to start asking questions about it, questions that you might be able to answer about it, and you're never going to see this picture quite the same way ever again. And that's what is science. Not just observing something, not just looking at something, yep, there's the Earth. Observing it, paying attention to it, and then seeing what stories we can tease out of the picture we see. Pretty cool, huh? It was so much fun, let's do it again. I've got another picture of another planet. This is Mars. Now, this is the best picture of Mars that we had when I was in school. It was taken from the 61-inch telescope in Arizona in the mid-60s, a telescope designed for really good, sharp images of the planets, but it's kind of fuzzy. The irony is that there are amateurs in this room who could make much, much better pictures today using techniques that were simply impossible, not because the telescopes were any worse, but because the cameras are so much better. But this was not only the best you could do with a camera back in 1970, it also is pretty much what Mars looks like when you're looking at it through a telescope with your eye to the eyepiece. Mars is really dinky. There are times when it gets kind of big, but most of the time it's pretty dinky in your telescope. If your name is Percival Lowell, and you've just invested in one of the best telescopes in the world in 1890, 1895, and you're standing outdoors, you have to be outdoors with a telescope, and you have to be as cold as the telescope to stop the telescope from shimmering up the air, and your eye is peeled to the eyepiece, because back in those days, the best and only detector they had was the human eye, which is still a pretty amazing detector. And you stare, and the Earth's atmosphere is shimmering the light, and it mostly looks like this, but every now and then, you will get an instant of brightness and an instant of sharpness. Nowadays, how the amateurs make good pictures is they have a video camera that runs and takes thousands of pictures, and then they select the ones that are those moment of brightness and add them together. But they didn't have cameras then, they had the human memory. If you're Percival Lowell, you're mostly looking like that, and what you see is, of course, Mars has got two different colors. There's a bright area and a dark area. And what the colors are depend on what you're seeing at moment to moment. And this is a copy of a slide of a color picture, and other people looking at the colors might see slightly different colors, but let's just live with the colors we've got here. What would you call the bright stuff? Probably you'd call it yellow. It's probably more like a yellow-orange. And then the dark stuff. You might call it brown. You might call it gray. When Percival Lowell was looking, what he actually saw was an olive green. Now, you notice there are a couple of white splotches at the north and at the south. Okay, we have white splotches on the Earth at the north and the south. They're called the pole caps. So clearly, Mars also has pole caps. It's got a little bit of cloud over here in an area that they actually called the clouds of Olympus, Nix Olympus, because there tended to be clouds there. Turns out there's a big mountain there. We didn't know that in 1895. But what you do see is that one cap is bigger than the other because just like the Earth, Mars is also tilted. And first one side of Mars and then the other side of Mars is tilted towards the sun. It has summers and winters. And here's the cool thing that Percival Lowell noticed. Percival Lowell noticed. When the Martian southern cap especially is in the summertime, the pole cap shrinks. Well, that makes sense. The ice is melting. As the pole cap shrinks, the areas that are this olive green in the south begin to grow. There's more and more areas that are turned olive green. And then in those instants of perfect seeing, he can see what look to him like straight lines, and he's not the only one who has seen these straight lines. A fellow named Schiaparelli also saw them, so they must be real, right? Well, that's the part of Mars that they were looking at, and that's what Hubble saw, and there are no straight lines there. Well, maybe Hubble just wasn't as sharp as Percival Lowell and Schiaparelli, because Lowell realizes he can explain everything he's seen. The pole caps melt, the water flows through these channels that look like straight lines. Maybe they're actually artificially made channels, which cause vegetation to grow, turning the area olive green. It was all perfectly logical, and it was all perfectly wrong. For one thing, the pole caps, they're not made of water. They're carbon dioxide on top of water. They're dry ice. The real colors of the olive green, they're not olive green, it's actually gray. When you have something that's really bright orange, your eye tends to make the gray parts next to it the complementary color, so you tend to think you see green when it actually isn't green. The canals are an optical illusion. It's the effect of doing in your head what, I don't know if you've ever done Photoshop on a computer, you used unsharp masking. You wind up introducing artifacts by overcompensating. When you've got dark spots next to bright spots, you can almost imagine lines between them. The same dark spots were there. Everybody saw the same dark spots, so everybody saw the same optical illusion. And what appears to happen is that the carbon dioxide pole cap, when it gets warm, turns into carbon dioxide. It sublimes directly from the ice to the gas. And that means that the atmosphere, which is carbon dioxide, becomes significantly stronger, and all of this gas creates a strong wind which blows off the red dust that's been covering the gray rocks. That's also science. Percival Lowell had a perfectly clear description of what was going on in Mars, and most of what he saw was there. And he had an explanation that explained what he saw on Mars, but just because he had an explanation didn't mean it was the explanation. And you keep testing, and you keep going back, and you say, well, if that's true, then bigger pictures should show the canals, and I don't see the canals. If that's true, then I should be able to see that the ice caps have the reflection of water ice, and in fact, they don't. And if that's true, et cetera, et cetera, et cetera. Science never deals in proofs, because science always knows that there's more than one possible explanation for the evidence that you see. If anybody ever tells you that science has proved such and such, the only thing they're proving is that they don't really know what science is. Science doesn't deal with proofs. The best science can do is to give you the odds of how likely it is that this is what's going on compared to what that. Let me give you an example. You walk into a room, you see a switch of a whole bunch of lights, you try to figure out which of those switches controls the lights. So you walk up, you press a switch, and the lights go off. Ah, I found the switch. Maybe. Story of a VIP who was visiting Milwaukee back when they just opened their domed baseball stadium. And the mayor of Milwaukee was bringing him to the baseball stadium before a game. And the mayor knew that the dome was going to open at exactly 7 o'clock. So at 6:59, he hands his television clicker to the VIP and says, push this button and you can open the dome. And the guy pushes the button and the dome opens. How do you know that when you pushed that button, somebody in the back of the room wasn't actually flipping the real switch? You don't know for sure. Well, you could try it again. You could flick it, and then the lights go on, and you flick it again, the lights go off. And the more times you flick it, the more times you're convinced this is really, unless there's somebody in the back of the room who's watching you and exactly mimicking what you're doing. When you've come up with a law, maybe all you're doing is designating a conspiracy of nature, a conspiracy to fool you. When I was a kid, everybody knew that Mercury kept the same face to the sun, because every time they looked at Mercury, it was oriented so that the same face was towards the sun. But you can only see Mercury every 88 days, and actually only 2 orbits, every 88 plus 88, whatever that comes to 176 days, 176 days. It turns out that Mercury doesn't turn once every 88 days, but 1.5 times every 88 days. And so by a weird coincidence, they were always looking at Mercury at the same orientation, but Mercury didn't keep the same. And it was only when they bounced radar waves off it, they realized they were wrong. Scientists report their findings with statistics. And the statistics show just how confident you are. If you have a 3 sigma result, that means that the odds are 1 out of 1,000. Only 1 out of 1,000 that you're wrong. 999 out of that's pretty good, unless you're dealing with millions of data points. And then there's going to be a whole heck of a lot of them that are outside of your 99.9% security. The history of science is littered with theories that were logical, well supported by observation, well supported by experiment, but nonetheless turned out to be wrong, like Percival Lowell's. But notice what that means about the internal attitude that you have to have when you're doing science. First of all, you have to admit ahead of time you don't have all the answers, otherwise you wouldn't keep looking for the answers. Second, you have to be humble enough to admit that at any point along the way, you could go wrong. That's why you constantly test your experiments, your theories with experiments, and then you test your experiments with theory. There's this big argument about the two of the different sides. I was in Italy 10 years ago at a science meeting, and we're all drinking coffees after the meeting. We're all sitting around a table, people from all over Europe. And I remember this guy was going on at great length about terrorists. You can't trust terrorists. Terrorists never listen to you. Terrorists think they know everything. Terrorists are just obnoxious people. And it was 5 minutes before I realized he couldn't pronounce the TH. But we need theorists. We need theorists to guide the experiment, just as we need the experimentalists to test and challenge the theory. Because we always know there's more to learn, that's why we can honor these books. This is Kepler's book. This is Newton's book. These are books actually from the Vatican Observatory, Specula Vaticana, 2nd edition of the Principia, only the 2nd edition. These are great books. I know there are some schools that have a great books program where they say, oh, we're going to learn physics by reading Newton. Well, number one, you probably are not going to read it in the original Latin. I hope not. My Latin can't do it. More to the point. Anybody here, anybody here students? You guys students? You taking biology? Would you use the same biology book that your mom used when she was in college? No, no way. You ever take a literature course? Would you use the same Shakespeare, copy of Shakespeare that your mom used? Why not? Maybe she's got good notes in the margins that you can steal for your course. What's the difference between Shakespeare and biology?
There's a lot more experiments done in the past 20 years.
More to the point, more than just that we've learned science books go out of date. Here's the deeper point. When you're studying Shakespeare, Shakespeare is what you're studying. When you're studying biology, you hope that you're studying nature. Nature doesn't change, but our understanding will change, just as a textbook about Shakespeare might go out of date faster than the Shakespeare itself goes out of date. But science books go out of date. Theology, philosophy, literature doesn't go out of date. Now, which do you think the Bible is? Is the Bible a book that's going to go out of date in 5 years? Or is the Bible something different from a science book? Okay, just about it. This is a Catholic school, so I guess I can mention this, that people who want to read the Bible literally, as if it was a science book, as if it was the owner's manual for your Volkswagen, it's a very modern idea. St. Augustine rails against this in a book called, ironically enough, On the Literal Interpretation of Genesis. And he says basically, if you try to read Genesis this way, you're throwing all of Scripture into disrepute, along with looking like a fool. This is the year 400. This is nothing new. I will also mention that, of course, the idea that the Bible is supposed to be read in this literal fashion is a Protestant idea. It's not a Catholic idea. Protestants are heretics. You know what we do to heretics. I guess there are a couple of Protestants in the room. Sorry about that. But there's something more going on than just this. It's more than just we're learning new things. You know, Mars doesn't have canals. The Mars that the Hubble Space Telescope saw looks really different from the Mars that Percival Lowell thought he was seeing. But it's actually Mars. Mars is Mars. What changed was not only the equipment, but also the expectation that we brought to the image. The things that we thought we could, actually I've got, you're the fourth person to bring me water. Thank you very much. All right. I'll add this to the others down here. The expectation we bring to the picture changes what we expect to see. Because science is done by human beings, and human beings are people with expectations. Personal, non-rational human urges control not only how we see the science, but even the questions we think are worth asking or not worth asking. Science is not something that can be done by computers. Science is a very human activity. Let me give you an example. Here's a pendulum. Back and forth, back and forth. You're getting sleepy. If you are Aristotle and you see a pendulum wandering back and forth, what's the one thing that you notice always happens? It runs down and stops. Sooner or later, it's going to run down and stop. And it always stops with the pendulum hanging straight down. Common sense. And from this and other observations, he comes to the understanding that this pendulum has some natural place it wants to go to, and it's seeking its natural place. If you're Galileo and you watch the pendulum, the story goes he was watching a lantern in a church. Must have been a really boring sermon that day. And he's timing it with his pulse, so I guess there was no excitement in the sermon. But he notices even as it gets shorter, it takes the same amount of time. The period of the pendulum stays the same, whether it's a big swing or a small swing. Turns out it's a tiny bit different, but more than he could see. If you're Newton, you have a totally different way of thinking of pendulums, and you say, the only reason it comes to rest is because there's friction in the pivot. If I could oil it, I could make it last longer. If I had a perfect pivot with no friction, it would swing forever. Same pendulum, 3 totally different lessons drawn from it. And all of them are correct because we know that Newton's laws mean we can build a clock using the pendulum as a timekeeper, like Galileo said, and yet Aristotle's right, you got to wind the clock once a day. And the point of winding the clock is to overcome the friction. And what all three of these people did was to take a videotape and do something that the video shouldn't and couldn't do, which was to extract from it, abstract from it, lessons about nature itself. It's a human activity. It's something that just a video cannot do. You've all been taught about the scientific method. A scientist observes a problem, comes up with a hypothesis, invents an experiment to test the hypothesis. In fact, I've never known a scientist to actually do that. Usually a scientist has a new hammer, bangs things until it breaks, figures out what questions can I get from this banging, and then how can I get money to solve it, and what meeting can I go to? But let's take the scientific lesson, the method, just as we're given. You observe nature. Okay, why did you decide to observe that bit of nature and not the bit of nature over there? You devise a hypothesis. Well, as we've seen, you can come up with hundreds of hypotheses, including the idea that there are little angels inside the pendulum that are swinging their way. How can you prove that it's not true? I challenge you to prove that it's not true. Of all the different hypotheses, how do you choose the one you're going to study? How do you get the idea for the experiment? What makes you think the experiment is going to show you one thing or another? Science and the history of science is littered with people doing experiments that actually didn't prove a darn thing of what they thought they were going to prove, and maybe proved something completely different that they didn't even think was a problem until they saw the answer. But where do you get the idea to do these things? And where do you decide, okay, I've got enough information that I can go to that meeting in Houston next week? I've always wanted to go to Houston. Have you ever been to Houston? Going to Houston is not a good reason to go to a movie meeting, let's just put it that way. Great meetings in Houston, but it's not Michigan. Where do these ideas come from? Where do these instincts come from? What makes you think that any one explanation is going to be so good that it's worth me spending a couple of years chasing down that explanation, and it's worth having some committee decide to give you the money to go chase down that explanation? Take an example. Is there life on Mars? Great question. You know, Percival Lowell's idea that there was vegetation, we know that doesn't work, but still, it doesn't rule out the possibility that maybe there is life on Mars. Is there now, has there ever been card-carrying life on the red planet? Oh, who cares? So what? I was at a science talk once, and the guy had spent an hour discussing what he was talking about. The first question was, so what? I mean, why does it matter? Why should I care? Actually, a darn good question. The guy forgot to explain that. I can come up with all sorts of clever reasons why finding life on Mars would advance our understanding of life and eventually lead to better medicines or improved Teflon or something. That's not why we do it. There's a famous story of the 19th century physicist Michael Faraday, who was doing experiments in the laboratory in electricity. And the story goes, Disraeli, the prime minister, shows up in the lab. And the prime minister says to Michael Faraday, Mr. Faraday, of what possible use is this electricity? And Faraday looks him in the eye and says, someday, Mr. Prime Minister, you'll be able to tax it. Why do we do science at all? Why do we care? The thing that makes you care is, in a sense, your religion. It's the motor that gets you up in the morning, that keeps you up at night, that makes you want to go the next day into the lab and work a little bit more. But putting it aside, granting that it would be cool to find life on another planet, how do you go about looking for it? You can go to Mars. We've sent spacecraft to Mars. These are some of the spacecraft. We put spacecraft in orbit around Mars. So there's that volcano with the clouds over it, which we now call Olympus Mons. It's about the size of the state of Arizona, bigger than Michigan. We have places where you can see that it looks like there is some kind of fluid that flowed out. So maybe there's water there, even though there can't be water stable on the surface. There might be water underneath. And we've sent spacecraft with various instruments that grind into the rocks. We know that Mars has got heat, made the volcano. It's got air, kind of thin air, but it's still got some kind of atmosphere. It's got something that looks like fluids. There's nothing lacking for the things that might give us life. But we haven't actually seen any life there yet. There's another way to attack the problem. We've got meteorites. Meteorites, rocks from space, and some of these appear to come from Mars. How do we know they're from Mars? I was showing this Mars meteorite to Pope Benedict once, and he asked me, how do you know it comes from Mars? And so I said, because of the scientific che si può trovare in questo meteorite è possibile di dire, and of course, then he said, I speak English, so we explained it in English instead. His English was better than my Italian, and certainly better than my German. There were lots of different reasons to think that this small group of meteorites looked really different from all the other meteorites. All meteorites are 4.5 billion years old. These meteorites were 1 billion years old. They could only come from a body bigger than even the moon, because the moon was the youngest rocks in the moon are 3 billion years old. But along with all the other arguments, there were some meteorites that had been cracked when they were launched up from wherever they were launched from. And in the cracking, the rock melted briefly and then froze into a glass. And in the glass were little bubbles. And you could carve around the bubble and take this little piece of glass enclosing a bubble and put it into your mass spectrometer. And you melt the glass and the bubble goes pop, and all the atoms inside the bubble are now in the vacuum of your mass spectrometer, shoot down the vacuum chamber and are deflected by a little magnetic field so that the heavier ones go farther and the heavier ones go farther, the lighter ones are deflected more easily. And you can count up every isotope and every atom and find out the composition in that bubble, and it exactly matches the atmosphere of Mars. So, and the atmosphere of Mars is pretty strange, very different from any other. So, either they're from Mars or from a body just like Mars. And there are no bodies just like Mars. And you go to Antarctica, that's me in Antarctica, and one of these Martian rocks, you carve open and you see little worm things that look like fossilized worms. And you go, well, maybe, but let's check. There's polycyclic aromatic hydrocarbons, the kind of stuff that organic stuff turns into when it rots. There's tiny grains of sulfide, just like organic. There's tiny, tiny, tiny magnetite crystals of a very high purity, like you only see made by bacteria on Earth. But of course, the bacteria use the magnetite crystals to find their way in oceans when there's a magnetic field, and there was no magnetic field on Mars, but there used to be a magnetic field on Mars, and it's a pretty old rock. 4 lines of evidence, all of which are consistent with these being fossilized bits of life on Mars. But every one of those 4 lines of evidence you can explain without life. There are all sorts of artifacts in rocks on Earth just caused by carbon dioxide attacking the surface of the rock that give you things that look like worms. So the fact that it looks is like the weakest line of evidence. Where else can you get polycyclic aromatic hydrocarbons? How about the exhaust of the snowmobile that went up to the rock in Antarctica when they picked it up? Lots of places where you can get PAHs. Lots of ways that you can make magnetite, lots of ways that you can make sulfide. So it would require 4 different things happening in this one rock. Now, Occam's razor. Occam's razor says when you've got 2 different ways of explaining something, you choose the simpler way. Which is simpler? To say what we see is caused by 4 different things going on that we do know happen, all happening to happen at the same place at the same time, or one explanation which is really, really significant if true, namely life. Which is simpler? A friend of mine, Tim Swindle, did a survey in the next year at this meeting in Houston where he talked to the space scientists, and half of them said, is this worth studying? Is this worth following up? Half of them said, yeah, there's maybe a 1 in 10 chance that it's true, but it's worth following up. And the other half said, you've got to be kidding. There's not one chance in 10 that this is true. And both groups came up with this 1 in 10 out of nothing. But even though they were coming up with the same odds, they came to totally different conclusions as to whether it was worth following or not. Because science is done by human beings, and human beings are people. And people make choices, and the choices are based on instinct, intuition, flavor of the day, what you're afraid your friends are going to say if they laugh at you by doing one or another, the desire to find something important, the desire not to be laughed at. All of these things go into what makes you a scientist. The philosophers of science have this marvelous phrase. They say every experiment is theory-laden. It means when you do an experiment, you already have an idea in the back of your head of what you're going to see. If you didn't have that idea, you wouldn't recognize it when you saw it. You can't do science without that. But it also means that you're either tempted to see what you were looking for, or you're unlikely to see the thing that you weren't expecting to see. There's this wonderful story about Einstein. There's Einstein there. Einstein come up with the general theory of relativity. It's a testable theory. While he's in Germany in the 20s, some guys at Cambridge devise a way of testing it, and they show that the theory doesn't work. And so somebody goes to Mr. Einstein and says, aha, you see, they proved your theory was wrong. What do you have to say? And Einstein goes, well, obviously, the experimenters made a mistake. How could you say that? And he goes, God is subtle. He's not malicious. In other words, my theory is so beautiful, it's got to be true. Does that sound like science? Turns out he was right. They had made a mistake. How do you know if God is subtle or malicious? What does it mean? Taste is one of those things that you have to learn. How many people here in this room think that, Elvis on Black Velvet is the height of beautiful art? How many people know people who think that Elvis on Black Velvet is the height of art? Why did somebody decide that Elvis on Black Velvet is silly? Taste is something you have to learn. That's one of the reasons you go to school. One of the reasons why you can't teach yourself science. Another person in this picture, by the way, the guy with the funny collar. Also, if they had MIT rings back then, which they didn't, he could have worn one of these. He was a Belgian priest named Georges Lemaitre, and he was a mathematician, the kind of mathematician who could read mathematics the way that you might be able to read a poem. And he had read the math of Einstein's general theory of relativity and said, you know what this means? This means that the universe is expanding. And Einstein says, well, your math is great, but your physics is crazy. And he says, no, really, I think, well, you know the rest of the story. In the 1950s, Fred Hoyle hated the idea of an expanding universe because he says that priest is only coming up with it in order to rescue Genesis. And I'm not going to believe in this Big Bang theory of his. At the same time, this amateur astronomer in Rome with the funny hat, Pius XII, reads this and goes, hey, the astronomers have just proved Genesis. Father Lemaitre, who incidentally was a diocesan priest, not a Jesuit, people want to call him a Jesuit. It is possible to be a smart guy and not be a Jesuit. Lemaitre goes to the Pope and says, Your Holiness, don't say that. My idea of an expanding universe from a point comes out of the science, but the science could be wrong. And 1,000 years from now, we may have completely different questions and a completely different explanation. And what's more, you know and I know that when we say God created the universe, we are talking about a God who is outside of the universe. What is the opening line of Genesis? In the beginning, God's already there. God's already there at the beginning. God's there before there is space or time. God promotes the possibility of space and time existing so that the physics that gives us the Big Bang might go on. The late Stephen Hawking died yesterday. Wrote a book a few years ago saying, I've proved there's no need for God because I have a different way of explaining the Big Bang theory. It's a quantum fluctuation in the primordial background because space can be warped, and if there's a slight fluctuation, then you might going to have mini Big Bangs, and if you wait long enough, and you've got all sorts of time, the warping of space, which we call gravity, could, by accident at one point, make a warping so big that it gives us the Big Bang. And if that's the case, and we don't need God to start the Big Bang, therefore there is no God. You go, wait a minute. To you, God is the thing that starts the Big Bang. And now you're saying gravity is the thing that starts the Big Bang. You haven't proved there's no God, you've just proved that God is gravity. Maybe that's why Catholics celebrate Mass. I'll let the physics majors explain it to the rest of you. But in any event, the Big Bang is not God creating the universe. It's how God did it, if the Big Bang happens to be true. My scripture tells me God did it. My science tells me how he did it. That's easy enough. But the idea that there could have been a creation point probably did occur to Lemaitre, and he wasn't horrified by the idea the way that Fred Hoyle was, simply because having grown up with the idea that the universe had a beginning meant that this was not an inelegant way of looking at the universe. So we're back to the black velvet problem. What is elegance? What is beauty? What is a scientific theory that satisfies? What do I mean by elegance? When I was a kid, I wanted an MG. MG was the most gorgeous looking car ever made. I have since talked to people who have had the misfortune of owning an MG. It looked great. It really didn't run very well, if it ran at all. I did not wind up driving an MG. What I wound up driving was one of these. Now, it ran, but it was not beautiful. And my apologies to anyone in the room who's related to anybody who designed the Plymouth, but it was not a beautiful car. Elegance, to me, has to have both a beauty and a functionality combined. And at the cost of offending my fellow Michiganders, this is what we wound up with. After a while, you realize not only was it practical, but it had a certain form equals function beauty to it that you couldn't beat. Maybe you remember this wonderful ad that Volkswagen ran. It's the Moonlander and the line, it's ugly, but it gets you there. That was Volkswagen. That was elegance. Elegance has applicability to a lot of choices we make in life. There are certain lifestyle choices that look very attractive but aren't very practical. Telling your boss where to go, maybe you shouldn't do that. Running off to the South Seas with this beautiful model. Yeah, sounds great until the third day when you realize that she can't cook and I can't fish. Great for daydreams, not really. That's like the MG of life. On the other hand, you don't want to be so practical, like Richard Dawkins is said to have said, he's since denied it, that children should not read Harry Potter because magic makes them unscientific. Give me a break. Where is the joy in life if you can't daydream? This is where the joy is in life. The universe is full of joy. To deny beauty is to deny reality. All right, if beauty's so essential, what is beauty? A lot of people get mad because they can't quantify beauty. Do you know what a millihelen is? A millihelen is an amount of beauty sufficient to launch one ship. Helen had the face that could launch 1,000 ships. Never mind. You can't do that. But even rationality is something that you can program, but you can't really. All men are mortal. Socrates is a man. Therefore, Socrates is mortal. Piece of logic. You've all learned this in logic class. How do you know that all men are mortal? There's some of us who haven't died yet. How are you sure that Socrates is a man? Maybe he was an alien. How do you know that the proper conclusion that all men are mortal and Socrates is a man is not that Socrates is, mortal, but that all men are Socrates? All men are mortal, therefore mortals are all men. And Socrates is a man, therefore all men are Socrates. How do you make these connections? Logic is taught. Logic has to be taught, and anybody who's ever tried to teach logic knows that it's not easy to teach. You have to spend a lot of time getting used to it. I was in the Peace Corps. You heard about my friend of mine was teaching some kids, little kids who are, 7, 8 years old, and they're beating the heck out of this gecko, this lizard. He said, "Why are you beating up that lizard?" "Oh, it's a snake. It's dangerous." Do snakes have legs? No. Does this have legs? Yes. Is this a snake? Yes, yes, kill it! Physics is like beauty. Physics is like logic. Science, you never understand it, you just get used to it. Too many people in our culture don't understand that science actually is poetry, and that sometimes poetry is the only way you can express the truth. What do I mean, poetry? My love is like a locomotive. Does that mean that I can actually draw, trains behind? No. It's a way of trying to express the strength of how I live. But it's a metaphor. Poetry is metaphors. The path of a falling apple is like the solution to this equation. It's a simile. It's poetry. And there are things that the apple does that particular equation actually doesn't solve, like what happens when the wind blows at it. When people ask for a literal meaning of the Bible as opposed to a scientific meaning, they're completely misunderstanding both the Bible and science. Symbols are symbols precisely because they represent something that's true. Every word is made of letters, every littera. But every word made of letters is itself a symbol for something that otherwise we don't have a word for. And there are things in the universe that are beyond any words that we've been able to describe, like God. A good choice of a symbol, an elegant choice, is one that does the job of communicating its truth to and its beauty. Mathematics, for that reason, is full of wonderful symbols, understood across cultures, and powerful because it's also beautiful. And the first time I ever heard the word elegant in terms of science was from a mathematics professor. This was a truly elegant proof. Elegant? Oh, that's the right word to describe that. There are other branches of science, botany, geology. You look from that thing and try to say which of those different kind of synclines is it, and you look at that piece of rock and you say, which of these pictures am I looking at? I can't do that with mathematics. I have to spend enough time with rocks to say, yeah, okay, I see what's happening. I had a wonderful friend of mine describing going to a geology class, structural geology, and the professor is explaining how you see that symbol in there, that kind of, and is that a plunging or is that a horizontal, and how can you tell the difference? And my friend is going, got it. He says, I only got it because I trusted the professor knew what he was talking about. But if I hadn't believed it, I would never have seen it. The opposite of what you usually hear. You need to have a faith that what you're seeing is there and worth looking at. The human equation explains not only what you're looking at, but why. Every scientist who's become a scientist has done so for reasons of the heart, reasons that reason doesn't know. Maybe you're Carl Sagan, and you're an atheist, or at least an agnostic. He once said to a friend of mine, an atheist is somebody who knows more than I do. But even though he wouldn't believe in God, he did believe in truth, to the point where he dedicated himself to the truth, to the point where he would never fake his data to make it look like he had discovered life and get all the accolades, even though he desperately wanted them, because he knew the truth was more important. That abstract thing, truth, which to me is the kind of God I believe in. Or you can be Buzz Aldrin here on the moon, who actually brought with him the Presbyterian host and wine and had a communion service on the moon under Apollo 11. Okay, it was Presbyterian communion service, not the real thing, but still. Truth and beauty. Truth and beauty are abstract concepts, transcendent ideas. They're words which religion uses to describe God. They're traits like love that allow us to recognize God. They're traits like hope, traits like faith. They can't be measured or weighed, and yet without them, you wouldn't bother doing the measuring or the weighing. In order to do science, in fact, you have to accept 3 articles of faith that frankly are religious. You have to believe the world actually exists. You can't be a Zen Buddhist who says, everything is illusion. If everything's illusion, I've got nothing to study. You have to believe that the world operates by laws. If you didn't believe in laws, you wouldn't look for them. But if you were a Roman and you thought everything happens because of nature gods, then you wouldn't bother looking any further. And if you think that God started off the Big Bang because God's just another force like gravity, then you're reducing God to a nature god, a pagan god. But you have to not believe in those gods. I'm not an atheist, but I only believe in one more God than the atheists do. We're not that far apart. There are a lot of gods out there I don't believe in. And to be an atheist, you have to have a very clear idea of the God it is that you don't believe in. Otherwise, how do you know you don't believe in him? And more often than not, I don't believe in that God either. The third thing you have to believe in, though, is that the universe is worth studying. That the universe is so good that chocolate is just part of the universe designed to drag you into perdition. Or acne, even worse. Chocolate is evil, like everything in the universe. No. Chocolate is a sign of God's love. The joy that you get from chocolate is a taste, a foretaste of the joy that you get when you see God face to face. Which is the view of the universe that you're going to believe? Is the universe evil? In which case, studying the universe would be, wallowing in evil. Or is the universe good? You have to believe in a good universe to want to be a scientist. It's a cliche to say that science and religion operate in 2 watertight compartments. And the trouble with that picture is that science doesn't exist without a scientist. Religion doesn't really exist without a believer. Both of them are human attributes, and often it's the same human who believes in a universe that is rational and beautiful and good, and for that reason wants to get closer to the universe by doing science. It's not that science and religion are competing ways of doing the universe. It's that religion is the foundation that gives me the reason to want to do the science and the faith to say that the science is actually going to tell me something that's true. Science and religion intersect without doubt in at least one point in the human being who's the scientist. In the human being whose ultimate motivations and yearnings to pursue science, overtly or not, are religious. And the one whose ability to do science is tied to their ability to find and recognize that mixture of truth and beauty that I call elegance. Thank you very much. So, if you have questions, please come to the microphones. There's one on either side. Line up, and feel free to ask questions about anything. If I don't want to answer them, I won't. You know, everything from the science I've talked about, my own science. You know, what does the Pope have for breakfast? I have no idea. Feel free to ask.
Just as a reminder, on your seats, there are evaluations. If you would take a minute before you leave to fill those out, there's boxes in the back of the room on both sides. Thank you.
And do we have those sign-up sheets for the foundation? Yeah. There's also some sheets in the back table if you want to know more about our foundation and the work we do. Sign up there and you'll get on our emailing list. I promise you won't be flooded. It's about once a month we send something.
I was excited to hear that you study asteroids because the book Newton's Clock, where the author writes about, you know, if we could get a really good mathematical model of the solar system, we could solve it backwards. And wow, we could figure out how the solar system started. And in the book, it's revealed that we can't even go back 50,000 years. And part of the problem was the asteroids. They're crazy. Do you study this? Give me something I can take to my students.
There's the guy that really founded the use of chaos theory in studying planetary orbits, who won the MacArthur Fellowship, Genius Fellowship, is an MIT professor named Wisdom, which I find wonderful. He's actually spent a lot of time at the Vatican Observatory. His wife is a member of Opus Dei and very religious. The trouble is, if you have a nonlinear system, and orbits are, by golly, nonlinear systems, then they are subject to what's called chaotic behavior, where the tiniest error, the tiniest difference from reality in your starting position will lead to totally divergent results. The easiest way to think of it is you've got the prow of a battleship, and you're shooting BBs, and you shoot BBs, and they bounce off one way, one way, one way, one way, but as it gets to the very pointy part, if the wind blows slightly one way, then suddenly the BB is going to bounce off in the other direction. And you have to have if you have a perfect BB gun and a perfect battleship, then quantum fluctuations in the position of the BB will be enough to make it impossible to tell which way it's going to go. The complicated tugs of one planet or another are such that you're talking millions of years in the orbit of Mercury itself is only 88 days. So if you're going to include Mercury in your perturbations, you have to have a time grid that's much less than 88 days for millions of years. And the round-off error in any computer you could imagine is going to throw you into chaos. It takes longer than the universe evolved to calculate how fast and how the universe evolved. Yeah.
How does one come to work at the Vatican Observatory or be employed as a scientist by the Vatican?
Dumb luck. I joined the Jesuits because I was teaching at Lafayette College, and I said, small colleges, this is where it's at. These are the best things going, and I want to be part of this. I was teaching there and really loved it. My girlfriend and I had come to a mutual agreement that we both thought the other persons were wonderful people, but we didn't belong to each other or with each other. And so I'm, 40 years old now, what do I do with my life? If I join the Jesuits, I get to teach at a Jesuit school. So I joined the Jesuits thinking I could teach there. And under obedience, they said, no, you're going to the Vatican. You have to live in Italy, look at that terrible scenery, eat that horrible food. And by the way, here's the science you're assigned to do. Do good science. Tell us about it once a year. And under those terrible conditions, I've suffered for the last 25 years. The Vatican Observatory was handed over to the Jesuit order in about 1930. They said, you guys find the people to staff it. And so the Jesuits, which tend to be a mail order, only order, and an order of priests and brothers, we all live under the same community, working the same way. We have, in addition to the Vatican astronomers who are being paid by the Vatican, being paid so little that we couldn't possibly afford to. No normal person could survive in the salary I get, but if you pool all of our salaries together, we do okay. But we do have adjuncts who are lay people and from all over the world. interested generally in the things that complement the work we do. Men and women, they don't have to be Catholic. That's the one thing we ask. So you could be a scientist at a place like Aquinas, doing astronomy, and having a reason why you want to be affiliated with us, because we do work that complements your work. That's the way it works at the moment.
What country were you in when you were in the Peace Corps, and what's your understanding of dark matter?
I was in Kenya, and I went there to help people out, and they said the way you can help us out was to teach astronomy at the university, which is what I'd been doing before then. I don't understand dark matter, but I do enjoy seeing the experiments that people are making and the observations they're making to try to put limits on what dark matter is. Now, when you look at a galaxy and you apply Newton's laws to the stars in the galaxy, they don't work. And this was really pointed out by Vera Rubin, scientist who's got a degree from Georgetown, and actually was one of the first instructors at the Vatican Summer School in 1986, and should have won the Nobel Prize, but that's a different issue. And the first idea was, well, maybe there's just a lot of ordinary matter there that we're not seeing. But the more you study how galaxies collide, you realize, you can see from the bending of light around colliding galaxies, that the dark matter is passing through as if there's nothing happening, but the ordinary matter is being all mixed up, and the dark matter is still showing itself by the way it bends nature. So dark matter is not the kind of matter that you and I are made out of. Is it made out of particles? Is it weakly interacting massive particles, which are WIMPs, or is it massive, active, compact halo objects, which are machos? And the macho theory we looked at carefully by looking for them around Andromeda using our own telescope. Didn't see enough of them to make us think that that's what it is. So it's apparently some kind of weakly interacting particle that is an aspect of nature we don't know about yet. And 100 years ago, we didn't even know we didn't know, which is great fun. We're still looking. The best part about science, science is not a big book of answers. If it was, we'd keep throwing the book out. Science is the conversation we have about the things we see. And that's why you go to a university, to learn the conversation. I remember when I was a little kid, and we'd hang around the campfires at the summer cottage, and I'd hear the grown-ups talk, and I'd be in the shadows trying to figure out, what are they talking about? Why is everybody laughing then? Could I come up with something funny that everyone would laugh at too? And eventually, as you grow up, you learn the conversation and how to converse and what the conversation is about. And then you get to a point where you can speak up and you say something and they go, yeah, that's a good idea. That's what being a student is about. It's hanging out at the peripheries of the conversation, waiting to the time when you know enough that you can add something to the conversation. And we're at a point where we're open to lots of ideas about dark matter and even worse, dark energy. There's no shortage of stuff. I'll get you, but there's one last thing about this no shortage of stuff. My dad, who will turn 100 in April, so fabulous guy. My dad taught me as a kid, knowledge is like an island. The more you know, the bigger your island. But the bigger the island, the longer the shoreline, which is the boundary between the stuff you know and the ocean of stuff you don't know. The more you know, the more you realize you don't know. So if you ever meet anybody who thinks he knows it all, it's because his island is actually really tiny. Yeah.
Yeah, I was listening to Catholic Answers maybe about 1 or 2 years ago, and the host was saying that there is a resurgence in a belief of geocentrism. Where's that coming from?
It's coming from a couple of places. The idea that, the Earth is actually at the center, or even better, that the world is flat. There is a long tradition in America of doubting the experts. When I was a kid, I remember a friend who had this button that said, "Question authority." And I always wanted to say, "Question authority? Says who?" There's also an enormous temptation to what has been called Gnosticism. The idea of secret knowledge. I have the secret knowledge, and that makes me one up on everybody else. And because I know the secret website that has the secret knowledge. I know that. Worse than that, and I find this especially among my engineer friends. Most scientists, your reputation depends on whether people think you're crazy or not. If you're an engineer, your reputation depends on whether your widgets work. I don't care if you think you're crazy because I like your widgets. Most engineers work in big companies where they have utter contempt for the suits. They're convinced they're the smartest guys in the class. And if you think that you're smarter than everyone else, if your identity is, I'm the guy who's the smartest guy in the room, then why should I agree with everybody else in the room? I only show that I'm smarter than them by disagreeing with everybody else. And if I can come up with some clever reason to think they explain why the Earth is the center of the universe, and everybody else was wrong, ha ha ha, or the Earth is flat, or there are faces on Mars, or we faked the moon landing, or any of the other large collection of nutty ideas, it's all an ego trip to try to show that I'm smarter than everyone else. And I think that's where it's coming from.
That makes a lot of sense.
Yeah. No, the fact that it doesn't make sense makes a lot of it. Never mind.
Brother Guy, we got time for this last question here.
Okay, great.
I had a question related to good science. If good science over the next few years discovers lots of solid evidence of extraterrestrial life, how do you think that might change our view of religion?
Do you want the shocking answer? Don't tell anybody secret knowledge. It won't make any difference at all. It'll be a 3-day wonder, and then we'll be worrying about the latest breakup of the marriage of the latest pop star. And I'm saying that not just to be cynical. First of all, there was a survey done by Ted Peters at the Center for Theology and the Natural Sciences at Berkeley. Across every religion, including the atheists, everybody to 90% said, if we find life, intelligent life in the universe, that completely fits with my understanding of God and religion. And the fact that we haven't found it doesn't shake my theory of God and religion. So it's clearly not a critical experiment, because it only is going to confirm what I already believed. I've got a whole book, Would You Baptize an Extraterrestrial, that goes into it more deeply. But the real insight came from, I think it was Michael Crow at Notre Dame, who says, we already expect there to be extraterrestrial life. I think most people in this room would not be surprised. We'd be delighted. It would be thrilling for a few days. But it's already built into our understanding of who we are and how the universe works. You know, we all read a lot of great science fiction when we were kids. And I sure did. I still do. And for that very reason, it would be exciting for lots of reasons, but I don't think it would challenge religion. What would happen, I think, in the long run is it would cause our religions to grow. But the idea that we're alone in the universe is not a Christian idea. You find anywhere in the scriptures the stars singing with joy when they encounter their Creator. We have in the Christian tradition the idea of angels who have their own salvation story. We know we're not the only creatures in the universe. And in Islam, there's all the additional idea of jinns and other possible entities. And if we're all part of the same universe, made by the same God, then we're not even alien. We all came out of the same Big Bang. We're all subject to the same laws of physics and chemistry, so we're probably also subject to the same laws of right and wrong. And if you have intellect, I know I exist, I know you exist, and we have free will, I can decide I like you, but I don't like you, then I'm going to be open to the same temptations and the same possibilities of sinning and making bad choices and the same need for redemption. There's a wonderful bit in the Gospel of John where Jesus tells the story of the Good Shepherd and then says, there are other sheep who don't know me I have to go to now. You go, aliens! He probably actually means Gentiles, but still. It's not inconsistent with a universe where there are other intelligences. On the other hand, maybe we are alone. Maybe we are, in the entire universe, the only rational creatures out there. So either there's creatures beyond us or we're it. Either way, it's a sobering thought. Thank you, everybody, for coming here. This has been a great evening.
We want to thank you all for coming, and I think, Brother Guy, your whole point about science being a conversation, it's a conversation with the natural world, a conversation with each other, and you did it with such joy, and that's what it's also about, too. It's a conversation of joy and relationships. So thank you all for coming, and we hope to see you. Yes, thank you for being part of the conversation, and let's thank Brother Guy once more.
Thank you.